welcome to the channel Mani's Gate Tech Vision. In this lecture, I am going to solve GATE 2024 problems for the subject control systems. I have taken the instrumentation paper. The topics which I have taken is common for electrical, electronics and instrumentation. So all those branch candidates can watch this video. Let me start solving the problems. So this is the first problem taken from the topic time response analysis. The problem is consider the feedback control system shown in the figure, the steady state error. So they have given the condition for steady state error as limit t tends to infinity r of t minus y of t due to unit step reference input r of t. Okay, so they have given one block diagram. We need to find the steady state error value. First, I will write the normal formulation for steady state error. ESS in t domain, limit t tends to infinity of E of t. In S domain, limit S tends to 0 of S into E of S. So in this problem, they have given the condition for steady state error value as difference between limit t tends to infinity, difference between input and output, that is R of t minus Y of t. So let me convert this into S domain. Limit S tends to 0, S into Laplace transform of R of t is R of S. Laplace transform of Y of t is Y of S. Okay. Now I am going to use this formulation to find the steady state error value. So what is R of S? Already they have given the condition as unit step signal. So R of S is 1 by S. So we need to find the Laplace transform of output Y of S from the given block diagram. So let me find out. See here, this is Y and feedback is given as K. So this signal flow will be K into Y of S. So I am writing R of S and Y of S. Okay, let me find out. And here R of S is given as input for the adder and K Y of S is given as input for the adder. So here a positive of R of S, negative of K Y of S. So this signal flow will become R of S minus K into Y of S. So this signal, this is given as input signal for the system. System is having gain 1 by S into S plus 1. So the output Y of S, we need to find the Y of S will be equal to, what is input here? R of S minus K into Y of S. This is input. Input into the system gain is 1 by S into S plus 1. Okay. So let me simplify for Y of S here. So Y of S equal to R of S minus K Y of S into 1 by S into S plus 1. Okay. So let me simplify Y of S. When Y of S is taken as common, 1 plus K by S into S plus 1 equal to R of S by S into S plus 1. Okay. So let me simplify for Y of S. R of S is 1 by S. So 1 by S square S plus 1 by 1 plus K by S into S plus 1. Again, this is simplified as 1 by S square S plus 1 in the denominator S into S plus 1 plus K, the whole divided by S into S plus 1. Now this S plus 1 we can cancel, 1 S we can cancel. So the totally 1 by S into the whole brace, again S into S plus 1 plus K. So this is what we have found out for Y of S. Okay. Now we need to substitute in this steady state error formulation. Okay. So let me substitute ESS equal to S into R of S minus Y of S. So here S into, what is R of S? 1 by S. So already we found out for Y of S. Y of S is this value. So I am going to substitute that. 1 by s into the whole brace s into s plus 1 plus k. Okay. So this is limit s tends to 0. Here also limit s tends to 0. Okay. So s is common. So we can cancel out this for each term. Again, limit s tends to 0. 1 minus 1 by s into s plus 1 plus k. Okay. Now applying the limit, this will become 1 minus 1 by k, which is k minus 1 by k. So this is the answer for the steady state error value, k minus 1 by k. Now see the options. In the option A, they have given this value. So option A is the correct one for the given problem. Steady state error value is k minus 1 by k. Let me move to the next problem. This is a problem taken from the time response analysis of the second order system. The transfer function of a system is given. Choose the range of zeta and omega n from the following options such that the poles lie on the shaded region of the S-plane. So we need to find the range of natural frequency and the damping ratio, that is omega n and zeta, from the given condition of pole region. Okay. So they have given the shaded region. The pole should lie in the shaded region. So here one angle is given and here one value is given. So from those values we can find out the range. See here, this angle is given. So we can find out this angle from 180 degree. So this will be 60 degree. Okay. So normally in the S-plane, and here they have given the value as 2. So normally in the S-plane, when two complex poles occur, we can draw the right angle triangle. This is theta and hypotenuse is omega n and this x-axis value is zeta omega n. Okay, this we know. So from this we can find out the cos theta and here this hypotenuse value is omega n. So here in this hypotenuse is given. It can be ranged from 2 to this side. It can be ranged from 2 to this side. Okay. So this value is omega n. So we can write the range of omega n as omega n may be equal to 2 or greater than 2. May be equal to 2 or greater than 2. So we have concluded with the omega n range. Now observe the option. In option A, we are having omega n greater than or equal to 2. And in option B, we are having omega n greater than or equal to 2. Now we need to find the range whether zeta is greater than or equal to 1 by 2, greater than or equal to 1 by 4. So already we have found out the theta as 60 degree. Theta equal to 60 degree. Now what is cos theta? Cos theta is zeta omega n by omega n. That is adjacent side by hypotenuse. So the omega n gets cancelled. Cos theta equal to zeta. So either the poles should lie in the shaded region. So it may, either it may lie from cos 60 degree to 0 degree or to minus 60 degree. Okay. So 0 to 60 we can find out the range. We know cos 0 equal to 1. Cos 60 equal to 1 by 2. So either zeta may be less than 1 or greater than 1 by 2. So it is a range between 1 by 2 to 1. So what is the range? 1 by 2 to 1. So here see the options A or B. Is it A or B? A should be the correct one. Okay. So we can conclude with the A. Zeta greater than or equal to 1 by 2. Okay. So thus we can find out the range for zeta and omega n. So thus we solved two problems from the instrumentation paper. This is Manish Gate Tech Vision. This is a channel for engineering lectures. You can view the lecture series freely. Thank you very much for watching the video.